Let's look into question 1a. Y equal to 4x plus 10 in power of 5 multiplied by ln 4x plus 1. Since it is a polynomial function multiplied by logarithmic function, so we are gonna to use product rule. It is dy dx equal to, let u equal to 4x plus 10 in power of 5, then du dx equal to, we bring the power of 5 into the front, so it becomes du dx equal to 5 in bracket 4x plus 10 power of 4 d multiplied with d dx 4x plus 10. Then du dx equal to 4x plus 10 power of 4 multiplied by 4. Then du dx equal to 20 in bracket 4x plus 10 in power of 4. Let v equal to ln 4x plus 1. dv dx equal to 1 over 4x plus 1 multiplied by d dx in bracket 4x plus 1. Then dv dx equal to 1 over 4x plus 1 multiplied by 4, and dv dx equal to 4x plus 1. dy over dx equal to 4x plus 10 in power of 5 multiplied with 4 over 4x plus 1 plus ln 4x plus 1 and multiply it with 20 4x plus 10 in power of 4. Simplify it into dy over dx equal to 4x plus 10 in power of 5 over 4x plus 1 plus 20 4x plus 10 in power of 4 ln 4x plus 1. Factor out the common term, which is 4x plus 10 in power of 4. So it will be dy dx equal to 4x plus 10 in power of 4 in bracket 4x plus 10 over 4x plus 1 plus 20 ln 4x plus 1. So now let's look at question B. Y equal to cos 3x minus 2 over exponent in power 2x minus equal to v du over dx minus u dv over dx over v square. Since we have the differentiate cosine function, it will become negative sin. Du over dx equal to negative sin 3x minus 2 multiply d dx 3x minus 2 minus 2, that is for u. So it will be dv over dx equal to e 2x minus in power of 2x minus 5 multiply d dx 2x plus 5 2x minus 5. Now we have all the components, then we have substitute it back into the quotient formula. To x minus 5 square. Notice that we have a common factor of exponent in power of 2x minus 5 in both terms of the numerator. Let's factor it out so we can cancel it with the denominator. X minus 5. And that is the final answer for 1.
Let's go. Let's get into it. So here's the question. Alright, find dy dx for 10x cubed minus 4x sine y to negative 1 over exponent to the power of y plus 5 ln x 3 minus y by implicit differentiation. So here's the catch. We're going to find the dy dx for this equation by using implicit differentiation. Right. So we're gonna do right now is going to differentiate every term. Right. So that's it. Alright, as I said just now, we're going to focus on the left side first, and then we're going to focus on the right side. We will get 30x squared. That's it. Going to 30x minus 4 sine, as you can see right here. So there's a 4x cos y times dy dx. You get me? Now we're going to focus on the right side. So the right side we get ddx exponent to the power of negative y plus ddx 5 ln 3x minus 1. So we will get negative exponent, just like I said. There's no lot of changes. I'm going to write it down. Exponent to the power of negative y dy dx plus 5. Alright. We will get 15. So here it is. And so for the left side we got 13 over 3x minus 1. So that's the equation. So we're gonna do x, we're going to find, it's time for us to find the dy dx. Cos alright, minus 3x minus 1. So for the left side we're going to factorize it. Check out the dy dx. So now we can finish as we to previous time. So the 15 3x minus 3. Let's write it all over again. And that's what we're gonna do since dy dx. Happiness. Cheers. Here's our dy dx. It's already done. Settle. Alright, thank you.
I'm Muhammad Adandarish, Ventil Mardi, student ID 2025-849-402. Today, I'll be covering question 3 of assessment MAT183, which is about linear approximation. How? Let's go! Question 3. Use linear approximation to estimate the value of 2 over square root 80.44 plus 4 square root 80.44 correct to 3 decimal places. So the answer needs to be in 3 decimal places. Now we're going to take a look at the general formula first, which is fx equals approximate equals to f prime x naught times delta x plus fx naught, where delta x equals to x minus x naught. For the first step is to find function. The function is basically taking this and turning the 80.44 into x. So we get 2 over square root x and plus 4 square root x. Taking things into power, we get 2 over x, 2x negative 1 over 2 plus x 1 over 4. The next step is finding the x naught and the delta x. X naught is that I chose is 81. Why I chose 81 is because when I put 81 into here, replacing 80.44, you get an exact integer. So, using the formula delta x equals to x minus x naught, we replace it, we get negative 0.56. The next step is finding the fx naught. Basically, we take the fx function that we have and replacing it with x naught, which is 81. So, replacing it 2 over square root 81 plus 4 square root 81 equals to 29 over 9. So, the next step is finding f prime x. So, basically, we take the fx that we got in the function that we got in the beginning and differentiating it. F prime x equals to 2 times negative 1 over 2, x to the power of negative 3 over 2 plus 1 over 4, x to the power of negative 3 over 4. And then bringing it down, we get negative 1 over x to the power of 3 over 2 plus 1 over 4, x to the power of negative 3 over 4. And then the next step is replacing the x with x naught in the f prime x. So we get negative 1 over 81 to the power of 3 over 2 plus 1 over 4 times 81 to the power of 3 over 4. And then we get negative 1 over 729 plus 1 over 108. The next step is I basically get the denominators and multiply it with the other top. So 729 times 1 and 108 times negative 1. Then adding them up and I get 621. And then multiplying both 729 and 108 to get the denominator 78,721. And then dividing it by 9 and 3 on both numerator and denominator, I get 23 over 2,916. And then using the first general formula that we have, which is fx approximately equals to f prime x naught times delta x plus fx naught. Replacing it, and we get 23 over 2,916, which is f prime x naught, times negative 0.56, which is the delta x, plus 29 over 9, which is the fx naught. And we get negative 0.004417 plus 3.2222. And the final answer we get is approximately 3.2178. And that's it for question 3.